The point of this tutorial is to show you yet again one more way to add your proposed contours showing the fill that's going to be placed on an elevated bed. You can use this technique for sloping or for flat fields, but you may find that for a level field it isn't any faster than doing it manually. So I'm going to illustrate how to do it for a sloping field. Now what we have here is a pretty steep site, and I've placed an Enviroseptic field with 6 rows at the 100 contour, and you can see that the top row is, the center of the top row is more or less parallel to the existing terrain. So we're interested now in finding where the finished grades will be, showing those contours for the contractor. We're going to assume that the bottom of that highest row, the invert of that highest row, is at grade, meaning it will be at 100. The finished grade over the field is 2 feet higher because we have the tube, which is 12 inches thick, and 6 inches of sand, and then another 6 inches of loam to bring us to the finished grade of 102. We have to start by finding out just exactly what is the slope of this site. Something that I haven't illustrated in earlier tutorials is how to get to a calculator. Let's come down to the command line and let's type in CAL, and it will bring up the generic Windows calculator. And you're wondering, well, how is that going to be useful to us? Well, let me demonstrate. This one's going to be a little easier because I purposely made it nice, convenient numbers, but we want to determine what is the slope of the site and the field, because we're going to parallel the terrain in the area of the field. Well, we're going to ask it how far these contour lines are apart. And it says they're 10 feet apart. And we know, so we have the horizontal change, which is 10 feet, and we know the vertical change. It is 100 minus 98, or 2 feet. So you've probably already done the math in your head, and you've determined that the site slope, and in this case the system slope, will be the same, which will be 20% or 0.2. Let's walk through it. Slope is defined as rise over run. Well, our rise, or the change in vertical elevation, is 2 feet. And the run is the horizontal change in distance, which is 10 feet. So 2 divided by 10 equals 0.2. And to get to percent, you would multiply times 100, and we get to the 20%. But we want to use the 0.2 directly. So the site changes 0.2 feet vertically for every foot change horizontally. So if we have a 10-foot change horizontally, we can expect to have a 2-foot change in vertical elevation. So that's the process that I go through. The numbers that we're using here are nice, easy. You could do the math in your head, but if you had an odd site with some odd spacing in your contours, this is the process that you would use. Alright, I'm going to delete that dimension. We don't need it anymore. So we know our site slope and our system slope in this example are 20%. Now let's go to the command that Carlson offers, and it can be found under the Surface menu, and you'll scroll down until you find Design Pad Template. I just call it the Design Pad command, And depending on which version of Carlson you're working in, it may be found in a different location, but it will be under the Surface menu. So let's select that. We're presented with a dialog, and it's got quite a few options, but let's start at the top. It needs a surface model to work with in creating these contours. And so it wants to know whether there's a surface file or we're going to use screen entities. Now, if you'd contoured the site using a TIN file and you saved that file, then you could select surface file. But you don't need it. Carlson makes it really quite convenient, and I typically will find that I'll use this command, screen entities. So I've selected that in this case for this example because I don't have any point data behind the contours on this in this particular example, but they are elevated properly. The next question that we need to answer is the slope direction from closed P-lines or polylines. Now we're sort of getting ahead of ourselves here, so you're not going to understand why we need to select outside, but it's enough to say that we're going to draw a polyline around this field and we want to contour away from it or outside of the polyline, because inside the polyline will be where the field itself resides. So outside is what we will typically use for septic system design. It then wants to know how should the contours be projected, and you will pick pad polyline because we're gonna show it, we're gonna give it the perimeter of where the fill is going to change to 3:1 or 2:1 depending on what overfill slope you've chosen to use, but typically it will be 3:1. Then we need to tell it what format this overfill slope is going to be presented to the program. Is it going to be a ratio like 3:1, 4:1, 2:1, which is what I typically will use, or as a percent? You can choose to use percent if you like, but I think you'll find it's much easier to work with ratio. Then we have a number of options that we're not going to use, and we're going to come right down to use slope pad design. We want to make sure that that is selected, and it asks us what is the percent slope of our again, Carlson is calling it a pad. You could also think of it as a parking lot. In our case, it happens to be the finished grade of a leach field, and it is going to be sloping, and it slopes from a higher elevation to a lower elevation, so we need to give it a negative value. So in this example, we discovered that our slope was 20%, so we put in minus 20%. We then want to round the exterior corners of our contours, because in most states we're only required to carry the fill extension beyond the tubes or the field a specific distance. We're going to use 5 feet in this example, but in other states it could be 3, 4, or more. And we want those contours to be rounded. You'll see exactly what this means once it's drawn those contours. And I leave this option checked, erase previous pad entities, in case you want to go back through this same procedure. It's very much the same as choosing erase previous contours when we generated contours. Then we come down to 2 commands that you can choose to alter if you want to obtain fill requirements or cut requirements for the contractor. The fill shrink factor is probably more useful to us because if we're working with a fill that's above grade, there won't be a cut. There'll only be fill. And what these numbers represent are, if you're going to place fill, will there be a compaction factor once it's been put in place? And we all know that fill does do that, does settle as you place it, and you may want to add 10% or 20% to the calculated fill volume so that the contractor can include that in their quote, so that that value represents something closer to what will actually be placed on the site. For this demonstration, we're going to leave the fill factor at 1, meaning the numbers that it's going to present to us are going to be the actual calculated fill requirements. And the same is true for cut. If you were hauling material away from the site as a result of a cut, then you might want to increase this factor. And finally, we're asked what layer we want to place the pad or the polyline that we're going to draw around the perimeter of our field, which will represent the extent of the fill extension, or what I call the fill extension, before the 3-to-1 slope or 4-to-1 slope begins. I just take the default. We say OK, and now we're being asked at the command line, because we told it we were going to generate this information based on screen entities, it wants to know the lower left limit of the disturbed area for these proposed contours in this pad design that we're going to go through. Well, I'm going to just window everything that I have here. And then it is going to create a grid file, which is its way of interpolating a surface based on these contours. Now, these contours shown on the screen have been elevated to the relative elevations shown, so the 100 contour is elevated at 100. Normally, this will default to 50. You can change it to any number you like. The larger the number, the more accurate the fill numbers, but we're really splitting hairs here. You may be off a couple of yards, not a couple of yards, I'm sure significantly less than that. But you can choose to use 50. In fact, let's do that. And select OK. And now it's looking for a pad polyline. Well, I forgot to draw it before we started this command. And I did that on purpose because this is a typical, I won't say it's an error, but it's typically what happens to me when I get in the middle of this. So I wanted to demonstrate no heartache. Let's just escape out of the command and let's go back and draw that polyline.